Hello. In the next series of our program of engines, we show a small emergency power plant that operates this portable radio. Okay, I'll just switch it on. Okay. The engine here, running a small alternator, operates this radio. I'll switch it off so that you can hear my dialogue better. Okay, let's start the camera here. And we'll talk about it a bit. Okay. What we have in front of us is a small hot air engine, or known as a Stirling engine. Okay. Here's a burner. It's real hot. This is the air carburetor. Air goes in here. This is a propane line. This is a water jacket here for cooling. Small water pump here to circulate the coolant. And then we have the radiator here. The power piston is here. The displacer cylinder and the hot end is underneath. Hot end is underneath the burner. Cold end under the water jacket, and the displacer piston, which runs with clearance in that cylinder, is inside. I'll just stop this so you can see it. Connecting rod, crankshaft, can be seen there. The lever amplifies the crank throw to give a longer stroke to the displacer piston, which is at the end of this rod. Okay. And this here is our alternator, permanent magnet, disc type, magnetized across the diameter, and two coils on sort of laminations produce the AC output. The AC is converted into DC by this device in the pill bottle here. There's a full wave rectifier. The blue part is a smoothing capacitor and a Zener diode to clamp the output voltage to 10 volts so as not to endanger the 9-volt radio. The engine, the basic engine, is described in Popular Science Monthly around 1962. Okay, this engine was one of the very first things I built in my own workshop in 1978. And some testing at that time led me to conclude that it would produce enough power to run the portable radio. Some experimentation was necessary to get the right configuration of coils, and it proved possible to run the radio. Now, most people that build a Stirling or hot air engine complain that the power output is just enough to keep it going, and this is basically true. It took a lot of effort to get this engine to produce enough power to do the job I wanted it to do. Extensive testing has proved that the mechanical output of this engine is 1 watt. The radio requires approximately half a watt, so at 10 volts that would be 50 milliwatts, and this engine produces that easily. So let's start the radio. Okay, so watch this as I slow down the flywheel. Okay, the radio dies down. If I start it up, the radio comes on again. So to make it self-contained, we added this radiator, water jacket. I'll turn this down off again. The water jacket, the pump. The pump is driven by a small spring belt. Yeah. And the electrical outlets for the alternator over here. The burner looks a little rough because the outer case is just a tin can. Might have been a tuna can or that. I don't remember, it was so long ago. And there you have it. Now this engine has run many hundreds, if not several thousand hours. Like I said, I built it in 1978, and in my workshop it's run this portable radio for every Saturday, or when I was in the workshop for a protracted period of time. It's run it. Okay. For long life, it's important to choose appropriate metals for different jobs. For example, the cylinder here, the power cylinder, is cast iron, and the piston inside is made of steel, close-fitting steel. Okay. The lubrication is with light machine oil. I use sewing machine oil. You can also use automatic transmission fluid, which is an excellent lubricating oil, very thin lubricating oil. The hot end is made of stainless steel, and if you can get 310, type 310 stainless steel, that's the way to go. If not, use 316 stainless steel, which is quite heat resistant. Same for the displacer inside. It is made of stainless steel. Now that all gives it long life expectancy. Like if you run it hard for power out, for lots of maximum power out. Okay. The radiator is made of copper basically. The crankshaft runs on 2 ball bearings, one there and one next to the flywheel. And that's basically it. Now, a permanent magnet alternator has no brushes, so there's nothing to wear out there. And that's it. So the way it's here, the engine could run until you run out of fuel. 1 pound bottle will probably, running the radio will probably run it, you know, I think for a week, if not longer. You know, you can lubricate it every few hours by stopping it, putting a drop of oil on water at various points, a drop of oil on the cylinder, and then it's good to go. This is an insulating brick because that burner gets quite hard, and to protect the wooden base here, the wooden turntable. The anti-slip mat is here to prevent it from slipping around because it does vibrate a little. The crank is not perfectly balanced. So there you have it. I term this my emergency home power generator. So if the power is out, I can at least have a portable radio for news and entertainment. It is possible to build a bigger one that would run a portable TV, or even a full-size TV now, because the new ones draw some new power. Okay, if you have any questions, just post it in the comment section below this video clip, and I'll be pleased to answer it. Okay? Thank you very much.